In this video, we're going to be talking about adding fractions. We're going to start off by looking at a word problem. Kayla is baking banana nut bread and muffins for a holiday party. She uses 2/5 bag of walnuts for the banana bread and 1/5 bag for the muffins. How much of the bag does she use altogether? So I'm looking for how much of the bag she used, and it says she uses 2/5 of the bag for the banana bread and 1/5 of the bag for the muffins. So I have drawn a visual. It's not the best visual, and we talked about how when you draw fractions, some of the limitations involve not being accurate on your drawings. So here's a perfect example. But I'm going to use this illustration to help me out first of all. So we know that she used 2/5 bag of walnuts for the banana bread, so I'm going to color in 2 of these. And 1/5 bag for the muffins. So just looking at this, we can see how many she used altogether. She used 3 parts of a bag that we divided into fifths. So she used 3/5. So that's using the visual, but I'm going to show you how simple it is to add fractions when they have the same denominator. So we knew that she used 2/5 on the banana bread and 1/5 on the muffins, and we know we're adding them together because we want to get the total. We don't have the total already. All you do is add your numerators. 2 plus 1 is 3. And the bag was cut into fifths. I do not add my denominators. I just keep it the same because you saw in that visual nothing changed. I didn't turn these into tenths. They stayed fifths. So my denominator is going to stay the same if I have a common denominator. So I can give you any problem, and this video is really quick because it doesn't matter what we're doing. We're just going to be adding the numerators. All the problems we're going to see have common denominators. We don't have to go finding the LCD on any of those. We'll look at that later in the year. So let's say that on the muffins, or let's say she baked some other stuff. She used 5/8 of a stick of butter on one thing she made, and then she used 3/8 of a stick of butter on something else she made. So how much butter did she use? 5 plus 3 is 8. Our denominator stays the same. 8/8 is really one whole. So she used one whole stick of butter, didn't she? On this student side, I'm going to give you a bunch of problems to work out, and I want you to solve them and pause me and then check your answers. So you should have paused the video so that you could have practiced these problems, and we're going to look at the answers now. Both of these have a common denominator, so my denominator does not change. 2 plus 1 is 3, so 3/4 is the sum of 2/4 plus 1/4. On the next problem, the denominators are common, so we keep it as 11. 5 plus 5 is 10, so 10/11 is our sum. Same thing here, they both have sevenths. 4 plus 5 is 9. Look at that, that's an improper fraction, so we're going to convert it to a mixed number. 7 goes into 9 one whole time, and I have 2 left over for 2/7. So I could draw that visual. 9/7. Think about it. 7/7 is one whole, and 2 left over would be 2/7. So 1 and 2/7. So you do have to convert your improper fractions into mixed numbers. All right, let's look up here at this one right here. Both of them have eighths, so that stays the same. 3 plus 3 is 6. Well, now I see something else. Those are both even numbers. I have to reduce always. So I'm going to divide by 2 because that is the number that both of them are divisible by. 6 divided by 2 is 3. 8 divided by 2 is 4. So 3/4 is how much this sum equals when you simplify it. So look at this. We've already used several of the concepts that we've been learning in the last few weeks. We've talked about how we have to have common denominators. We've talked about how we have regular fractions. Sometimes we have improper fractions that we have to convert into mixed numbers, which is using that ice cream cone method. And we also have shown in this one how If you can reduce it, if you can simplify it, you need to simplify it.